In this video, we will see further problems from exercise 8.2. So, question number 11 says, if vector A, B and vector C are given by this, then find the magnitude and the direction cosines of first vector A plus B plus C, and the second is this. So, let's start with the first one. So, the methodology that we would follow here is, we can add the three vectors, A vector plus B vector plus C vector, and you'll get your resultant vector. And from this vector, let's say this is in the form xi cap plus y j cap plus z k cap. Then the magnitude is equal to square root of x squared plus y squared plus z squared, and the direction cosines are, if let's say this is the resultant vector as r, then that's the magnitude. Then your direction cosines are x by r magnitude, comma y by magnitude of r, and z by magnitude of r. So it's very simple. So let's proceed. Let's do the first part of the problem. So vector A plus vector B plus vector C will be written as, let's bring down the three vectors, 2i cap plus 3j cap minus 4k cap plus 3i cap minus 4j cap minus 5k cap plus minus 3i cap plus 2j cap plus 3k cap. So adding the 3, we get 2 plus 3 minus 3 will be 2i cap. 3 minus 4 plus 2 would be 3 minus 4 is minus 1. Minus 1 plus 2 would be 1 plus j cap. Then minus 4 minus 5 is minus 9. Minus 9 plus 3 will be minus 6. Minus 6 k cap. Alright, so the magnitude of, let's say, r vector is equal to ABC vector. So will be equal to square root of 2 squared plus 1 squared plus minus 6 squared. So that's equal to square root of 2 plus 1 plus 36. Sorry, 4 here. That is equal to square root of 41. So that's the magnitude of, therefore, the magnitude of vector A plus B plus C is square root of 41. Next, the direction cosines are, we can call the first one as 2 by root 41, 1 by square root of 41, minus 6 by square root of 41. That's the answer for the first part of the problem. Now let's solve the second part of the problem, which is 3a vector minus 2b vector plus 5c vector. So substituting the values here, 3 into 2i cap plus 3j cap minus 4k cap minus 2 times of 3i cap minus 4j cap minus 5k cap plus 5 times of minus 3i cap plus 2j cap plus 3k cap. Further simplifying this, 6i cap plus 9j cap minus 12k cap minus 6i cap plus 8j cap plus 10k cap minus 15i cap plus 10 j cap plus 15 k cap. Simplifying this further, we have the 6 and 6, it gets cancelled, so minus 15 I cap minus 15 I cap. Then 9 plus 8 is 17 plus 10 is 27, 27 j cap. Then you have minus 12 plus 10, which is minus 2 plus 15 will be plus 13 k cap. Let R be the vector, resultant vector, so that is equal to magnitude of k. So we can write that as square root of minus 15 squared plus 27 squared plus 13 squared, which is equal to square root of 225 plus 729 plus 169, which is equal to root of 1123. Therefore, the magnitude of 3a vector minus 2b vector plus 5c vector is square root of 1123. The direction cosines are minus 15 by root of 1123, comma 27 by root of 1123, comma 13 by root of 1123. And that's our answer. Question number 12. The position vectors of the vertices of a triangle are given by these three vectors. Find the perimeter of the triangle. So what is our methodology here? So for a triangle, the perimeter is the sum of the sides. So what we're given is the position vectors of the points A, B and C. So we need to find the vectors AB, BC and CA. Then you have to find the magnitude of AB plus the magnitude of BC plus the magnitude of CA, and that will be the perimeter of the triangle. So let's proceed. So let's define vector OA is equal to I cap plus 2 j cap plus 3 k cap, and vector OB as 3 I cap minus 4 j cap plus 5 k cap, and vector OC as minus 2 I cap plus 3 j cap minus 7 k cap. So let this be our triangle with points A, B and C. Okay. Next we need to find vector AB. Vector AB is vector OB minus OA, and that's equal to 3 minus 1, that's 2 I cap, minus 4 minus 2 will be minus 6 j cap, 5 minus 3 will be plus 2 k cap. Similarly, our vector BC would be equal to OC vector minus OB vector. So minus 2 minus 3 is minus 5 I cap, 3 plus 4 plus 7 j cap, minus 7 minus 5 will be minus 12 k cap. And our vector CA will be equal to vector OA minus vector OC. So vector OC, OA, which is I plus, so it's 3 I cap, and 2 minus 3 will be minus j cap, 3 plus 7 will be plus 10 k cap. Therefore, the magnitude of AB vector will be equal to square root of 2 squared plus minus 6 squared plus 2 squared. This is our AB vector, yeah? So that's equal to square root of 4 plus 36 plus 4, which is equal to square root of 44. Next, let's find the magnitude of BC vector. That would be equal to square root of BC vector is here, minus 5 squared plus 7 squared plus minus 12 squared. So that's equal to root of 25 plus 49 plus 144, and that would be equal to, adding them up, you will get 218. Similarly, the vector CA magnitude would be square root of 3 squared plus minus 1 squared plus 10 squared, and that's equal to square root of 9 plus 1 plus 100, which is equal to root of 110. Therefore, the perimeter of the triangle is root 44 plus root 218 plus root 110. That's the answer. Question number 13. Find the unit vector parallel to 3a vector minus 2b vector plus 4c vector if vector A, B and C are defined like this. So what's the methodology that we would follow? So you are given 3a vector minus 2b vector plus 4c vector. So substituting the values of a vector, b vector and c vector into this, you would get a resultant vector. Let us assume it to be xi vector plus yj vector plus zk vector. Now the unit vector which is parallel to this will be defined as, let's say this is the vector r. So if I'm going to define the unit vector as r cap, it's going to be the vector r divided by the magnitude of r. This will give you the unit vector, right? So let's proceed. 3a vector minus 2b vector plus 4c vector will be equal to, substituting the values of a vector, b vector and c vector, we get 3 into, substituting the values of vector a here, 3 I cap minus j cap minus 4k cap minus 2 times of minus 2 I cap plus 4 j cap minus 3k cap plus 4 times of I cap plus 2 j cap minus k cap. Now further simplifying this, it's 9 I cap minus 3 j cap minus 12 k cap plus 4 I cap minus 8 j cap plus 6 k cap plus 4 I cap plus 8 j cap minus 4 k cap. So taking all the coefficients of I cap and simplifying further, 9 plus 4 is 13 plus 4 is 17. 17 I cap minus 3 minus 8 is minus 11. So it will be minus 3. Minus 3 j cap minus 12 and plus 6 will be minus 6 minus 6 minus 4 minus 10 minus 10 k cap. So now the magnitude. So let's find the let's r vector be equal to this vector. So that is equal to for c vector is equal to the square root of 17 squared plus minus 3 squared plus minus 10 squared. That is equal to square root of 289 plus 9 plus 100. So which is equal to root of 398. So the unit vector, the required unit vector is equal to vector r divided by the magnitude of r. So that's equal to vector r is minus 7, so plus 7 I cap minus 3 j cap minus 10 k cap divided by root of 398, which is equal to 17 by root 398 I cap minus 3 by root 398 j cap minus 10 by root 398 k cap. So that's the unit vector.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.